Welcome to my presentation on decentralized operating systems, enhancing data privacy through blockchain integration. My name is Emmanuel Vergara, and I will be sharing with you my research on the potential of decentralized operating systems, particularly those leveraging blockchain technology to address critical issues in data privacy. For the background and context, to begin, let's establish some background. Traditional operating systems, while fundamental to our digital lives, operate under centralized control. This inherent structure presents potential vulnerabilities and raises concerns about how our data is handled. In response, decentralized computing has emerged, fueled by the desire for more resilient and user centric systems. A key technology driving this shift is blockchain, with its distributed and transparent nature. My research specifically focuses on how these decentralized operating systems, built upon blockchain, can offer significant improvements in data privacy, a growing concern in our data driven world. The central problem this research addresses is the inherent vulnerabilities within traditional centralized operating systems that can lead to data breaches and compromises of our user privacy. Furthermore, users often have limited control and visibility into how their data is collected and used by these systems. This necessitates the exploration of alternative operating systems, architectures that fundamentally prioritize user data, privacy, and security, offering a more trustworthy computing environment. Moving on to the significance of the study. This research holds significant value as it explores the potential for fundamental shift towards more privacy respecting computing environments. And by investigating the centralized operating systems, we can understand how users can be empowered with great control over their personal data and digital identities. This study also contributes to the growing body of knowledge on how blockchain technology can be effectively applied beyond cryptocurrencies and to build secure and privacy preserving operating systems. To understand the context of decentralized operating systems, it's important to briefly look at the evolution of OS. We've moved from early batch processing systems to the centralized GUI based and network systems we use today. This evolution has largely occurred within a centralized framework, and in contrast, decentralized computing distributes control and resources across multiple nodes. Decentralized operating systems take this further, aiming for distributed control, enhanced security, and greater user autonomy. A key enabler for these systems is blockchain technology, which provides the necessary foundation through its decentralized nature, immutability, transparency, and the functionality of smart contracts. While the potential of blockchain for enhancing privacy in various applications is increasingly recognized, its application to the core operating system layer is still a relatively big field. There is a limited comprehensive analysis of the different architectural models that could be employed for building fully decentralized operating systems. And furthermore, more research is needed to understand the practical implementation challenges and the hurdles that need to be overcome for the widespread adoption of this innovative approach. The methodology employed in this research is a comprehensive literature review. This involved utilizing specific keywords such across various academic databases, research repositories, and industry reports to identify relevant literature. And the collected sources were then analyzed to synthesize, to extract key concepts, compare findings, and ultimately identify the research gaps that this paper addresses. So, moving on to the presentation of findings, which is conceptual, and there are no graphs or tables. So, based on the reviewed literature, several key findings emerge. Firstly, blockchain technology offers a strong foundation for decentralized operating systems due to its inherent properties like decentralization, immutability, transparency, consensus mechanisms, strong cryptography, and the powerful functionality of smart contracts. In contrast, traditional operating systems exhibit various vulnerabilities and raise significant data privacy concerns stemming from their centralized nature, extensive data collection practices, and limited user control. Decentralized operating systems, particularly those leveraging blockchain, offer several mechanisms to enhance data privacy, including decentralized data storage, strong encryption, user centric control through self sovereign identity, and transparent audit trails. The integration of blockchain into a decentralized OS provides numerous advantages for privacy, such as reducing the risk of single point data breaches and increasing user trust and control. Finally, the literature suggests several potential architectural models for building such systems, including a fully blockchain centric approach, a hybrid model combining traditional kernels with blockchain layers, and microservices based decentralized architecture. So, in summary, the key findings of this research indicate that decentralized operating systems, particularly when integrated with blockchain technology, present promising solutions to address the significant data privacy vulnerabilities inherent in traditional centralized systems. The literature highlights several key mechanisms through which these decentralized systems can enhance privacy, including the distribution of data storage, the implementation of strong encryption, the empowerment of users with greater control over their data, and the provision of transparent audit trails. Ultimately, the fundamental properties of blockchain technology make it a strong candidate for building operating systems that prioritize security and respect user privacy. Moving on to the practical applications and future research directions. So, the potential practical applications of decentralized operating systems are significant. They could lead to more secure and privacy preserving personal computing environments, empowering individuals with greater control over their data. These systems also hold the promise of being more resilient and resistant to censorship, and they can provide a strong foundation for decentralized applications that prioritize user privacy. Looking ahead, future research needs to address several key areas. This includes tackling the inherent scalability and performance limitations often associated with blockchain technology in the context of an operating system. Developing effective governance and coordination mechanisms in the absence of a central authority is crucial. Ensuring the security of smart contracts and decentralized applications that run on these OS is paramount. We also need to investigate the user interface and user experiences challenges to make those systems accessible to a wider audience. Exploring hybrid architectural models that can balance the benefits of decentralization with performance efficiency is another important direction. And finally, understanding and overcoming the real world adoption hurdles will be critical for the successful implementation of decentralized operating systems. So, in conclusion, this research highlights the significant potential of decentralized operating systems, particularly those built upon blockchain technology, to offer more privacy respecting computing environment. While considerable research and development are still required to overcome existing challenges, the potential benefits for user empowerment and data security are still substantial. Thank you for your time.